Welcome to the deep dive. Today, we are strapping in for quite a ride, actually. We're taking a deep look at a visitor from interstellar space that has, well, it's really shaken things up in the astronomy world.
It really has.
We're talking impossible chemistry, strange behavior, and this blurring line between what's natural and maybe what isn't.
Exactly. We're diving into 3I Atalis, and this object, right from the moment it was detected, it just blew past all our expectations for what something from another star system should look like.
It's only the third one, right? After Oumuamua and Borsov.
That's right. The third confirmed interstellar object, or IO, but this one? It's different. It's massive, a true giant compared to the others. It's a messenger, you could say, from far away, and honestly, the data we're getting is forcing us to rethink our definitions of comets, asteroids, maybe even space itself.
Okay, let's start with that scale, because that's the first thing that just seems staggering. It's estimated to be bigger than 5 kilometers across.
Minimum 5 kilometers, yeah. To give you a sense of that, picture Manhattan Island and the weight. Estimated minimum mass is around 33 billion tons.
33 billion. Okay, let's pause there, because Oumuamua was, what, the size of a football field?
Roughly, yeah. Maybe a couple hundred meters long at most. And 2I Borisov, maybe a kilometer wide, tops.
So we went from seeing, like, pebbles skipping through the solar system to suddenly seeing an island drifting in.
Precisely. And that size difference alone is a huge red flag. It tells us something is, well, unusual, either about the places these things come from or maybe about what we're actually capable of seeing.
And we know for sure it's interstellar. No question about that.
No question. That's confirmed by its trajectory. It's moving on what we call a hyperbolic path.
Okay, hyperbolic trajectory. Break that down for us. What does that mean in simple terms?
It basically means it's going too fast to get stuck here. Think about throwing a ball up in the air. If you throw it hard enough, it escapes Earth's gravity, right? Same idea, but on a cosmic scale. This object is moving so fast that the sun's gravity can't capture it into a permanent orbit, like our planets or asteroids. It's just swinging by, using the sun like a slingshot, and then heading back out into deep space. It's a visitor, not a resident.
Got it. So our mission today, we've got this pile of sources, observations, scientific papers, some pretty controversial statements from experts, too.
Definitely controversial.
And we want to unpack what we're calling the 7 key anomalies around 3I Atlas. These are the things that have really split the scientific community.
Yeah, the sticking points.
So we're looking at 2 main stories emerging from all this. Is it just a really, really weird natural comet?
Yeah.
Or is it something else? Something, as people like Avi Loeb at Harvard are suggesting, potentially technological? Maybe even like a Trojan horse from somewhere else.
It forces you to consider it. When you dig into the details, the chemistry, the orbit, the simple comet label starts to feel a bit inadequate. You have to keep an open mind and look at these weird data points, whether they point to new physics we don't get yet, or maybe design.
Okay, let's ground ourselves first. What do we know for sure? The basics. It was discovered pretty recently, right? July 2025.
July 1st, 2025, yeah. By the ATLAS survey.
ATLAS.
Yeah.
That's an acronym for something, isn't it?
It is. Asteroid Terrestrial Impact Last Alert System. It's funded by NASA, basically designed to scan the sky for potential impact threats. It has telescopes in a few places, including Chile, which is where this one was first flagged.
And the system just picked it up because it was moving funny.
Essentially, yes. The automated software saw this object moving in a way that didn't match any known solar system body. Its path was just wrong.
And that's how it got the name 3I Atalis.
Exactly. 3 for third interstellar object, I for interstellar, ITLS for the Discovery program. Simple enough.
Did they find older pictures of it? Sometimes they can look back, right?
They did, yeah. Once they knew where to look, astronomers went through archival data and found images going back to mid-June 2025. Used data from a few different ATLA scopes and the Zwicky Transient Facility, ZTF.
Oh, okay.
And having those earlier observations was crucial. It allowed them to pin down the trajectory and speed very precisely, very quickly.
Now, before we dive into the weird stuff, this thing is Manhattan size, flying through the inner solar system. We need to be crystal clear. Is it going to hit us?
No. Absolutely zero threat to Earth. That's vital. People hear Manhattan-sized object and understandably get nervous, but its path keeps it very far away from us.
How far?
Its closest approach to Earth is in December 2025, and it'll be about 1.8 AU away.
And an AU is the Earth-Sun distance.
Correct. So 1.8 times that distance, roughly 270 million kilometers, give or take. Way, way further away than Mars usually is. We are completely safe.
Okay, good. But it did get closer to Mars, didn't it? And that's part of the weirdness we'll get to later.
It did. Closest pass to Mars was October 3rd, 2025. Came within about 29 to 30 million kilometers. And its closest point to the sun, the perihelion, happens October 29th, 2025. That'll be just inside the orbit of ours.
And the speed, you said it was fast.
Incredibly fast. When discovered, it was already doing about 137,000 miles per hour. That's 61 kilometers per second. And it's only accelerated as it gets closer to the sun's gravity as well.
So despite the size, the speed, the origin, astronomers initially just called it a comet. Why? What made them say comet right away?
The main reason was activity. This is the big difference compared to, say, Oumuamua.
Which didn't really seem to be doing much, right? Just moving strangely.
Exactly. Oumuamua showed that non-gravitational acceleration, but without any obvious outgassing, no visible cloud of dust or gas. 3I Atlas, though, right away showed signs of being active. It developed a coma, that bright, fuzzy cloud around the nucleus, and eventually a faint tail.
So ice vaporizing.
That's the assumption. Seeing that activity, that gas and dust coming off it, implies it has an icy core that's sublimating, turning straight from solid ice to gas as it gets warmed by the sun. And if it has ice and shows activity, the default classification is comet, even if it's a monster-sized one.
And we know what kind of ice. The Loeb telescope looked at it, didn't it?
Yes, Webb's infrared capabilities gave us a compositional snapshot, and it found something really specific. It's extremely rich in carbon dioxide ice, dry ice.
CO2 ice, not water ice.
Well, both, but overwhelmingly CO2. This is where, even if you think it's natural, it gets really fascinating. The analysis showed the ratio of carbon dioxide ice to water ice is about 8-to-1.
8 parts CO2 to 1 part water. How does that compare to our comets?
It's extraordinary. Most comets from our own solar system, especially the long-period ones from the Oort cloud, are dominated by water ice. CO2 is usually just a trace component, maybe along with carbon monoxide or other volatiles. An 8.1 ratio is, well, it's among the highest CO2 fractions ever recorded for any comet anywhere.
Wow. Okay, so what does that tell us about where it came from?
It implies it formed in an incredibly cold place. Carbon dioxide turns to gas, it sublimates, at much lower temperatures than water ice does. So for an object to hang on to that much CO2 ice over potentially billions of years traveling through space, it must have formed and stayed stored in a region of its home star system that was significantly colder than where our own comets formed.
Like way out in the boonies of its system.
Exactly. Maybe an equivalent of an Oort cloud that's much, much further out and colder than ours. Or perhaps even originating from the really dense, cold molecular cloud before its parent star even fully ignited.
So even under the natural explanation, this thing is like a pristine sample from a really alien environment.
It is. It's a time capsule carrying the chemical fingerprint of its birthplace. It gives us this amazing window into conditions and planetary formation processes way beyond our solar neighborhood.
That's where the consensus kind of ends, right? Because once you start looking closer.
That's exactly right. This is the point where the weird comet explanation starts to fray.
Okay, let's dive into those anomalies. The things that make scientists scratch their heads and say, wait a minute. Avi Loeb, as we mentioned, kind of grouped these into 7 issues. Let's tackle the big ones that really challenge the natural comet idea. We already talked about the size.
And it's worth hammering that point home. 5 kilometers, 33 billion tons. Why is the third interstellar object we find a million times more massive than the first one? Statistically, you'd expect to find way more small ones before you find a giant like this, assuming they're distributed randomly.
Couldn't the small ones just be harder to see, or maybe they burn up faster?
That's the counter-argument, yes. Maybe the little guys are fragile and evaporate quickly when they get near the sun, so we only spot the big, robust ones that can survive the trip. But still, the jump from Oumuamua's football field size to this Manhattan scale without finding many intermediates, it's statistically really odd. It feels like we skipped several steps.
Okay, so size is anomaly number 1. What's next? The weird jet.
Yes. The Hubble observation from July 2025. This was truly bizarre. Hubble captured an image showing a distinct jet of material coming off the object.
Okay, jets happen with comets.
But this jet was, first, very long and thin, about 10 times longer than it was wide. And second, crucially, it was pointing towards the sun.
Towards the sun. Wait, aren't comet tails always pushed away from the sun by solar wind and radiation?
Almost always, yes. That's the whole mechanism. Sometimes you see what's called an anti-tail, which is usually heavier dust particles left behind in the comet's orbit that, from our perspective, appear to point sunward. But this looked different. It looked like an active, focused stream of material being ejected directly at the sun.
How do they explain that naturally?
It's tough. Some suggest maybe highly uneven outgassing on a rotating nucleus. A specific vent just happened to be pointing sunward when Hubble looked. But the fact that a more normal, faint tail pointing away from the sun only appeared later, in August, it suggests something very unusual, maybe even controlled, about how this thing releases material.
And if it's releasing gas unevenly, that acts like a little rocket engine, right? Pushing it slightly off course.
It does. That's non-gravitational acceleration. And that ties into the third anomaly, its optical properties. The light reflecting off 3I8Las showed extreme negative polarization.
Negative polarization. What does that even mean?
It's a complex optical effect, but basically it suggests the surface texture or the composition of the dust particles scattering the light is unlike anything we've seen from normal comet dust. It's baffling from an optical physics standpoint, so you've got weird dynamics, weird optics. The natural comet picture is already looking strained.
But then comes the real bombshell.
Okay.
Chemistry. Anomaly number 4. The nickel problem.
This, for many, is the potential deal breaker for a natural origin. We know the plume is mostly CO2, which is weird, but maybe explainable by cold formation. What's not easily explained is the metal signature they found.
What did they find? What metal?
Using the Keck 2SECA telescope in Hawaii, doing spectroscopy on the gas cloud, they detected nickel. It was estimated to be venting about 4 grams of nickel every second.
Okay, comets have metals, don't they? From the dust.
They do. Asteroids, meteorites, they all contain metals like nickel and iron. But here's the critical point. In every single natural solar system object we've ever studied, comets, asteroids, meteorites, nickel and iron are always found together in roughly comparable amounts. They condense out of the protoplanetary disk together. They're chemically bound in the minerals.
And in 3I8Las.
They found the nickel, but no comparable trace of iron, just nickel being vented out. That breaks the fundamental rule of natural cosmic chemistry as we know it.
Just pure nickel, or was it in a specific form?
Even more specific, the analysis strongly indicated the nickel wasn't just raw atoms. It was in the form of a molecule called nickel tetracarbonyl. Chemical formula, nickel tetracarbonyl.
Okay, why is that compound such a big deal?
Because as far as we know, nickel tetracarbonyl doesn't occur naturally in space. It's a highly volatile, quite toxic and very specific compound that, on Earth, is primarily known as an intermediate product in a major industrial process.
Industrial.
Yeah.
Like man-made.
Exactly. It's key to the MON process, which is used worldwide to refine nickel ore to very high purity. You bubble carbon monoxide over impure nickel at specific temperatures and pressures. It forms this volatile nickel tetracarbonyl gas. You separate the gas, then heat it to decompose it back into pure nickel metal and carbon monoxide. It's used in making high-purity nickel coatings, catalysts, specialized alloys, things you find in advanced manufacturing in aerospace.
No, let me get this straight. This interstellar object is venting a chemical compound primarily associated with heavy industry on Earth, and no iron alongside it.
That's the finding. It's incredibly hard to explain naturally. You'd need some bizarre, unknown process inside the object involving concentrated carbon monoxide reacting with pure nickel deposits under specific conditions we've never seen or theorized for a comet nucleus. As Avi Loeb put it quite directly, this compound has never been observed for any other natural object. For many scientists, this chemical signature is the closest thing to a smoking gun pointing towards something engineered.
Okay, wow. So the chemistry points towards industry. Let's shift gears then. If what seems artificial, how its path, its timing also seem unnatural? This takes us into the statistical anomalies, right?
Yeah.
The things that seem too coincidental to be random chance.
That's the perfect way to put it. We move from chemistry that seems physically impossible in nature to orbital mechanics that seem statistically impossible by chance. And this is where the most radical idea gains traction. That 3I8Las isn't just weird, it's technology.
And this brings us back to Avi Loeb at Harvard, who's been very outspoken. He's the one suggesting it could be an alien mothership or something similar.
He is. He's publicly assigned something like a 30 to 40% probability that this object is not natural, which, coming from a tenured Harvard astrophysicist, well, it's a monumental claim.
How does he justify such high odds against the default natural explanation?
He talks about it in terms of Pascal's wager and uses a Trojan horse analogy. Pascal's wager is the philosophical idea that even if the probability of God existing is small, the potential consequences, heaven or hell, are infinite, so it's rational to believe. Loeb applies that here. Even if the probability of 3A Atlas being alien tech is, say, 30%, the implication confirming advanced extraterrestrial intelligence is so profound, so world-altering, that we must investigate it with the rigor usually reserved for, well, potential alien artifacts, not just weird rocks.
The Trojan horse part being, it looks like a comet, but might be something else inside.
Exactly. It might look innocent, like a natural object, but could potentially represent something far more complex, maybe even a threat, though there's no evidence of hostile intent, just the strangeness. He sees it as a potential black swan event, something unforeseen with massive consequences that demands we don't just dismiss the anomalies.
Okay, so what are the statistical anomalies that make him put the odds so high? These are the ones he says will be puzzling forever.
Right, because they relate to its specific path and timing, which are fixed aspects we've observed. The first is the ecliptic alignment.
The ecliptic. That's the flat plane where all the planets orbit the sun, more or less?
Pretty much, yeah. Think of it as the plane of the solar system's main highway. Now, objects coming in from interstellar space should arrive from totally random directions, right? Their home stars are moving randomly relative to us, so they could come in from high above the plane, way below any angle.
Makes sense. So what did 3I8 Tills do?
It came in almost perfectly aligned with that plane. Its trajectory is within 5 degrees of the ecliptic. The odds of a random incoming object just happening to line up that precisely with our planetary plane, about 0.2%.
0.2%, so like 1 in 500?
Exactly. It picked the path that hugs the plane of the planets instead of plunging in from some random angle above or below. That's statistically suspicious right off the bat.
Okay, that's one. What's the second puzzling forever anomaly?
The optimized timing for planetary flybys. This one is even more startling, statistically. It wasn't just aligned with the plane. Its arrival time and angle seem almost perfectly calculated to allow close passes near multiple planets.
We mentioned it passed near Mars.
Yes, but the trajectory was optimized for close approaches not just to Mars, but also to Venus and to Jupiter as it swings back out, all within a relatively short time frame. The probability of a random trajectory achieving this trifecta of planetary close encounters, it's estimated at 0.005%.
0.005%. That's, what, 5 in 100,000?
Pretty much negligible odds for it to happen by chance. It strongly suggests the orbit wasn't random, but potentially chosen or adjusted to allow for these specific flybys, maybe for gravitational assists, maybe for observation, who knows. But it looks engineered, not accidental. Natural objects just don't thread that kind of needle through the moving architecture of a solar system.
Okay, that's compelling. And the third one relates to something else entirely, the wow signal.
Right. Anomaly number 3, wow. Signal alignment. This connects back to that famous, unexplained, powerful, narrowband radio signal picked up by the Big Ear radio telescope back in 1977.
The one that seemed like a potential alien broadcast, but was never repeated?
That's the one. It came from the direction of the constellation Sagittarius. Now, fast forward to 2025. The direction from which 3I Atlas arrived in our solar system is aligned to within 9 degrees of the origin point of the WOW signal.
9 degrees. What are the odds of that alignment being random?
About 0.6%, still very low.
Why connect this object to a radio signal from nearly 50 years ago?
It's speculative, of course, but Loeb's point is, given the other anomalies, could this alignment be more than coincidence? Could the object be related somehow to whatever source produced that signal? Maybe it's a probe sent along the same path, or just following a galactic corridor. He argues strongly that radio telescopes should be listening intently to 3ILS, just in case this directional alignment isn't spurious. If it starts transmitting, well, that changes everything.
So you have industrial chemistry, and then these 3 incredibly unlikely orbital coincidences. Yet, the mainstream classification remains Comet.
And this is where Loeb really pushes back against what he sees as classification bias. He uses that analogy. Calling this thing a dark comet or a weird comet is like seeing an elephant and calling it a stripeless zebra. You're trying to force something truly anomalous into a familiar box because you don't have a box labeled alien technology.
Has this happened before? Have we mistaken technology for natural objects?
Oh, absolutely. There are documented cases. Famously, when SpaceX launched Elon Musk's Tesla Roadster into space, some automated asteroid surveys initially flagged it as a new near-Earth object until they realized what it was.
Okay, that's maybe understandable.
But a more significant case was in 2020. Astronomers discovered an object orbiting Earth and initially classified it as a small asteroid or a captured mini-moon. It took more detailed observations to realize it was actually the Centaur upper stage rocket booster from NASA's Surveyor 2 mission, launched way back in 1966. They eventually matched its brightness variations and spectral signature to stainless steel.
So we've mistaken our own leftover space junk for asteroids.
Precisely. And if we can get confused by our own decades-old technology floating around, Loeb argues, how can we be so certain about classifying something truly bizarre from another star system as definitively natural? The default assumption is always natural explanation, even when the data screams otherwise. Remember Oumuamua. It accelerated away from the sun with no visible comet tail. That's physics-defying for a simple rock, but because there was no obvious engine, the explanation got really convoluted. Nitrogen icebergs, hydrogen icebergs, solar sails made of something. The resistance to considering technology is immense.
And this resistance, coupled with the high-stakes potential alien tech, has led to this atmosphere of intense scrutiny, hasn't it? And maybe even hints of secrecy around the data.
Definitely intense scrutiny. The global scientific community mobilized incredibly quickly. Hubble and Webb got those early, crucial composition readings, the CO2 dominance, the weird nickel, the missing iron.
But the real crunch time was the Mars flyby on October 3rd, right?
Yeah.
That was our best chance for a close look.
Absolutely. Several spacecraft orbiting Mars were tasked to observe it. NASA's Mars Reconnaissance Orbiter, MRO, with its super powerful HiRISE camera.
HiRISE. That's the one that takes those incredibly detailed pictures of the Martian surface.
The very same. Plus, ESA's Mars Express and ExoMars Trace Gas Orbiter were also pointed at 3i Atlas. This was the moment everyone was waiting for, potentially the highest resolution images we could ever get of an interstellar object.
What exactly were they hoping HiRISE could show? Could it actually see surface details?
Not like craters or anything that small from millions of kilometers away, but the hope was for a resolution maybe around 30 kilometers per pixel. That's potentially good enough to get a much better idea of its true shape. Is it roughly spherical, like Borisov seemed to be, or elongated and weird, like Oumuamua was thought to be? Maybe even flat or disc-shaped.
And its reflectivity, its size.
Exactly.
Right.
Confirm the size estimate, measure its albedo, how much light it reflects. If HiRISE resolved it into something clearly non-spherical, maybe with sharp edges, or something incredibly reflective, well, that would be very, very hard to explain as a natural comet nucleus.
And this is where the secrecy angle really kicked in, particularly pushed by Loeb.
Yes. After the flyby, there was an unexpected delay in releasing the HiRISE images and data from the Mars orbiters. Loeb went public, quite forcefully, claiming NASA was effectively withholding crucial data.
Why? Was he suggesting a cover-up? Hiding aliens?
His public statements attributed the delay more to, well, bureaucracy. He mentioned a lapse in government funding that apparently led to NASA's communications department being furloughed or understaffed. So the data might exist, the scientists might have it, but the official pipeline to release it to the public and the wider scientific community was clogged.
So potentially hiding aliens because the paperwork wasn't getting done.
That was the ironic framing, yes. Loeb was scathing about it, saying things like, who cares about the communication departments? We want to see the data from the scientists. He demanded transparency, arguing the significance was too high for bureaucratic hurdles. But of course, that delay, combined with the object's weirdness and the nickel discovery, it just poured fuel on the fire of online speculation about a deliberate cover-up.
And all this public drama, the claims from respected scientists, it led to some pretty wild moments as the object got closer to the sun, didn't it?
It really did. Loeb himself made headlines with a rather cryptic warning, telling people to take vacations before October 29th.
October 29th. That's perihelion, its closest approach to the sun. Why tell people to take vacations then?
It wasn't entirely clear. Was he expecting a major data release then? Did he anticipate the object might break up or flare dramatically when exposed to the sun's intense heat? Or was it just a way to highlight the date's significance? Whatever the intent, it definitely sounded ominous and fed into the general anxiety and speculation online.
And inevitably, people started connecting it to prophecies, Nostradamus.
It's almost a reflex action with major cosmic mysteries, isn't it? The sources do mention that certain online communities quickly found vague quatrains attributed to Nostradamus that they felt applied. The one often cited goes something like, "From the cosmos, a fireball will rise, a harbinger of fate, the world pleads."
Vague enough to fit almost anything, really.
Pretty much. Astronomers dismiss it as just public fascination and maybe anxiety finding an outlet, but it shows how deeply this object captured the public imagination, tapping into those end of days or moment of contact narratives.
The observation campaign doesn't end at perihelion, though. We're still watching it as it heads back out.
Oh, yes. As it recedes from the sun and heads towards the outer solar system, there are plans for more observations. NASA's Juno spacecraft, currently orbiting Jupiter, will try to get a look. And ESA's Jupiter Icy Moons Explorer, the JUICE mission, will also attempt observations, likely in November 2025, and maybe again in March 2026 as it passes Jupiter's vicinity.
Why observe it after its closest approach to the sun?
Because that's when things might get really interesting. By then, much of that volatile carbon dioxide ice, the stuff making the coma and jets, should have boiled off due to the solar heating. We'll be seeing what's underneath.
So what are the possibilities?
Well, if it's fundamentally a natural comet, we might see a much clearer view of the remaining nucleus, perhaps a darker, denser, maybe somewhat cratered, rockier, icy core. If, however, it is technological, and the CO2 is maybe some kind of camouflage or ablative shielding, removing that outer layer might reveal an underlying structure that looks distinctly non-natural, maybe metallic, maybe geometric. These later observations could be decisive. The story is definitely not over yet. #outro. So let's try and pull the threads together from this deep dive. We have 3i Atlas, confirmed interstellar, third one we've seen. Officially, it's a comet because it's active, shedding gas and dust, but its size is enormous, Manhattan scale, way bigger than expected. Its chemistry includes that bizarre nickel tetracarbonyl signature with no associated iron something linked to industry, not nature as we know it. It had that strange sun-pointing jet early on, and its orbital path shows these incredibly unlikely alignments with our planetary plane and key planets.
Too many butts for it to be simple.
Exactly. The natural comet explanation feels stretched to the breaking point by these anomalies. The evidence challenging it seems, well, quite strong.
And yet, even if it is just an incredibly weird comet, its value is immense, right?
Absolutely. Regardless of its origin, natural or artificial, it's a physical sample delivered to our doorstep from another star system. Studying its composition, even the weird bits, gives us invaluable data about the kinds of materials and conditions that exist out there, how other solar systems might form. It's a scientific goldmine either way.
It really forces us to question our assumptions, doesn't it, about what's normal out there?
It really does. It pushes the boundaries of our definitions. We're looking at something that, based on our current understanding of solar system formation and comet composition, arguably shouldn't exist in the form we're seeing it.
Okay, let's end with that provocative thought, leaning into the possibility raised by Loeb and others. If 3i Atlas is technological, the source material mentions it could potentially even maneuver, maybe using the sun's gravity for a targeted exit path. Or, and this is the really sci-fi idea, maybe releasing smaller probes as it leaves. We haven't seen anything like that, but the possibility exists in theory.
It does,
Right.
purely speculatively based on if it's tech premise.
So thinking about that and considering the current, let's call it information bottleneck,
Yeah.
around the high-resolution Mars images and the near-zero probability of its orbital path being random, what fundamental assumption that we hold about our place in the cosmos, about maybe being alone, might be the next domino to fall when that high-rise data finally becomes public?
That really is the question, isn't it? When does overwhelming anomaly transition from weird nature to potential evidence of intelligence? What does design look like on an astronomical scale?
Something for all of us to think about as 3i continues its silent journey through our system. Keep an eye out for those data releases. Thank you for joining us for the deep dive.